This is going to be the 3-2 alpha lesson, okay? And we're going to start with the PDF. And the first thing is a definition. The definition or the distinction between interpolation and extrapolation. You're going to see that in one of the problems. But interpolation is when you make a decision about the data that's in between the min and max. And extrapolation is when you make a decision about the data that's outside the range, okay? And again, as long as you get inside versus outside, you'll see that when we do the problem set, okay? Definition of residuals is observed, take away, predicted. Now this is important because it's not the absolute value, okay? It is observed, take away, predicted. The SIGN matters. Now, this is new for you. Y hat. If there's a hat over the Y, that's the value you get by doing linear regression. So you got to look for that. That symbol is important. And then the line of best fit will minimize the sum of the squared residuals. So the easiest way to see that is for you right now to go to page 190. And on page 190, there is a picture, there's two pictures. One on the right, you have the price of a truck depends upon the miles driven. And you see the slope is negative, which is kind of logical, because the more miles on the used truck, the lower the price would be. So you see that diagonal line with the negative slope, that's the line of best fit. What's going to happen is the residuals, the points above the line that have positive residuals, and the points below the line with negative residuals, the residuals will add to 0. That's what the line of best fit does. So it's no good to us to have, that would be misleading, make us think that every point was on the line. So what we do is we square the residuals. But that is what's happened here in that picture. They literally built squares. And where are the squares? You drop a perpendicular from the point to the line of best fit, or you raise a perpendicular and you create a square from that dimension. And then you add up the area of those squares. The line of best fit would be, of all the possible lines you could choose, that one would minimize the sum of the squared residuals. And that will become clear to you as we go through this and we pick up on Thursday after tomorrow's assessment. So you're just going to one problem set, the same data, 37 and 39, and 41 is the same data set, but we'll do that together. So we're going to pause the video. You're going to go to problems 37 and 39. All right, so let's pick up here with this question 37. And they say this. You have this scatter plot, and the line of best fit's on there, okay? And they're telling you the input is payroll, and the output is number of wins. So if you had to describe this, right, you would say linear, positive, moderate. Does that make sense? It's not curved. As you go to the right or left, it's not taking a different shape. Certainly going up, then it's moderate, okay? They're giving you the line of best fit. So what the calculator did was this. You have something which is known as the grand mean. And the grand mean is the average of the input. So that's going to be somewhere around here, the average payroll, and the average of the output, number of wins. So you're going to have a line, a horizontal line that goes to the grand mean. And that line's getting rotated until the sum of the squared residuals is minimized. See, if you took, here you have a positive residual above the line of best fit. You added up all these positive residuals and all these negative residuals, the sum would be 0. So predict the number of wins if the team spends $200 million on the payroll. What do? We just put the line of best fit, which was given. See the hat over the Y? That's telling you it comes from doing regression. So we put 200 as the input, where we put the regression equation in Y1. And you get 88.5. Now, one thing you'll notice, see how it's written backwards? That's statistics speak. Doesn't matter, but we write the intercept first in statistics. If you wrote it the other way, it's equally correct. It's just the way it's done. So what does that mean? If you spend $200 million, you expect to win between 88 and 89 games. How about if you spend $400 million? 400 in the function generates 116 wins, which has only been done once in history. 2001, Seattle won 116 games, but then they lost and never made it to the World Series. But what's the difference? 200 is here. It's interpolation. It's inside the data set. 400's out here. Because the most money spent looks like 275 million. Ready? This is 2016. This wasn't the Phillies, but the Phillies are down here somewhere. 275 million. So 400 million's over here. It's extrapolation. So saying that you could be way more confident about this number, 88.5 wins, than the 116 wins by doubling the salary. Okay? 39. So let's go back to the problem. The Cubs won the World Series. They had 103 wins and spent 182 million. So let's find the Cubs. Here's the picture. Wins, 103. Well, there's only one team over 100. And here's 182 in payroll. So here are the Cubs right there. The Cubs have a positive residual because their number of wins is higher if you drop this perpendicular down than the line predicted. How do I quantify that? We put the money they spent into the regression equation, and it's telling you would win 86 games. They won 103. So they have a positive residual of 17 wins. Now, that's what every team's trying to get. You're trying to win more games without just trying to buy wins. You're trying to be smarter than other teams. That's where the Phillies are doing this evaluation on Clentak with his analytics. You're trying to say, for this amount of money, so if you look up here, here's the Cubs. There's two teams that had the same payroll as the Cubs. One team got right on the line and one team was below the line. So what separates the Cubs with the same payroll? And that's where you're trying to get in terms of management. Okay? And then 41, which we didn't ask you to do it, but it's the same data set. You gotta be careful about this. Interpret the slope of the regression line. So the slope, now if you look at this tells you Payroll in millions of dollars. There's the slope. So if we say $100 million, it's in millions, multiply this by 100, we multiply this thing by 100. Move the decimal point 2 places to the right, and we get 13.9. So to interpret the slope, for every 100 million increase in payroll, the wins would tend to go up by 14, 13.9. That's a tendency. That's not guaranteed. Okay, you can't, when you get a question like this, you can't say wins go up by 14. You would just say that they would tend to go up by. All right? And does the value of the y-intercept have any meaning? Well, no, the y-intercept 60.7, which means what? If you spend zero money on payroll, you're not going to win 60 games. You don't have any players. So what is that? That's extrapolation. It's outside the data set, so the intercept is meaningless in context of the question. Okay? Now, this, so that's all for 3-2 alpha.